Okay, so today we're going to cover entity relationship diagrams. You click on the slides here and you see these slides here, which we're going to go over today. And the quiz looks just like this. And we have these three entities here, agents, clients, cars, and properties. That's 4. And there's a relationship between these, which you are going to draw lines, special lines between these entities to that represent these one-to-one, either 1 to n or n to m relationships. So let's go through the slides. And this is pretty simple stuff. So you don't really need to read any more than this. There's just some certain things that you have to see, and they're all described very well in these slides, so you can refer back to the slides. Let me make this smaller, as small as I can. I don't want to do that where I'm actually doing the slides, because then it doesn't show the same thing on the two screens, on the overhead and my computer here. So data modeling and the entity relationship model. So we're going to learn about the role of the data model, the entity relationship data model, and we're going to learn how to interpret them. We're going to learn how to interpret and write this information engineering model's crow's foot diagrams, which I kind of like. It's the latest one that's become sort of a convention. And there can be recursive relationships, and we're going to learn how to draw them from source documents. Actually, that's sort of the exercise at the end. We're not going to go over that today, but you should be able to do that. Okay, so this chapter starts off by talking about the 3 stages of database development, and this is not a subject perhaps this subject should be included in a course like this, but this is from a more management information systems, or like if you having to learn databases in the at Scheidler, let's say you're going for a bachelor's of business and information management systems or something, then this kind of stuff is really important because oftentimes folks that do this kind of stuff don't really have a lot of experience building databases themselves. Having knowledge and understanding through experience of actually building and getting them to run. There's people that don't really care to do that part. They like the designing part of drawing the diagrams, knowing how this the topic of this lecture. But actually going further than that and writing a bunch of SQL statements and triggers and stuff to enforce the business rules, they're not so interested in that. That's sort of left to they might think the technician or something, which anyway. There's a systems development life cycle is an important thing to know about, I'm sure there's a class that covers just that in this program here in the ICS department. But let's get into these entity relationship models. And so the important elements of entity relationship models are there's entities and attributes and identifiers and relationships. And these are just the same or similar or slightly different terms for what we know about already. Entities are tables, attributes are the fields in the table, or the attributes of the table, the columns. Identifiers are keys, and relationships are, the understanding of relationships between the entities. This one-to-one, one-to-many kind of thing. There's an entity class is a description of the structure, of the format, of the occurrences of the entity, and then an instance would be an actual instance of it. Makes sense. We have so entity and this notion of instance and classes, we see that in all of our languages, in languages and so on. And it's a class defines a structure. It's like the class is the could be like the create statement if you're speaking of actually the implementation, like in SQL, and the entity instance would be the actual table with values in it, and would have a state or a state in time, whereas the class just defines the structure. And then the attributes here in this example, we may have a table that's got a project name, and a start date, and a type of project, and a description, and so on. They have properties. Identifiers are keys. I'm just going over the terminology first for this before we get further in this. Identifier types. There's identifiers can be unique or not unique. If it's unique, then it's then a value in that column or field can only occur once. That's unique. Composite would be like a composite primary key, or a primary key that's two fields. These are just different. This is just different nomenclature. When we describe entities, we choose the comprehensiveness, or how much information is displayed based on what we're trying to show, and oftentimes just saying the item, referring to the entity or the table which contains instances of items, can just be described like this, or sometimes we may want to just put the key value in there, and then other times, most of the time, we want to identify the key at the top that looks like this, and then have the other fields listed here. There's more stuff too, like these are primitive, data types, and we aren't describing. It's not necessary to describe those, in that level of detail. But what convention we do have is that if we have more than one entity, on the same page, a field, an attribute in one with the same name as an attribute in another entity would mean that they mean the same thing, and they refer to the same thing. And now we're going to talk about these relationships, and this is here. We have the relationship where suppliers in quotes. This is just a binary one-to-one relationship. We do have these alternative kinds of relationships where the mother and the father are the parent to the child, a ternary relationship. We're gonna in databases here, we're gonna talk about one-to-one, one-to-many, and many-to-many. And so those are the three basic kinds. One-to-one, of course, would look something like this, where we have an employee. An employee maybe one employee, one locker. An employee is assigned one locker. A locker is not assigned to, employees don't share lockers, and employees don't have more than one locker. Here we might have, in a database, we have an item, something like a parts database. We have an item, and we have maybe more than one supplier for that item, and we are perhaps looking for quotes. And so we may list, the database may list quotes for different items. And so that would be a 1 to n, where for one item you could have more than one quote from different suppliers, for example. And then here in the database, we may have several items, and each item is one-to-many relationship to suppliers, because an item can have more than one supplier, but also a supplier can supply more than one item. So that's shown like this. Maximum cardinality has to do with the maximum number of entity instances that may participate in a relationship. It's usually zero, well, one or many, or it can be some other fixed number in special cases, depending on the database, of course. And the minimum is the minimum number. It's usually 0 or 1, or it's optional or mandatory. So here's an example, or here's the way to denote the cardinality of both minimum and maximum if we use this nomenclature here that we have been using, which is not crow's feet, by the way. I'm going to switch over to crow's feet. I'd like you to use crow's feet in your quiz today. And there's going to be an assignment also. I'm going to ask you to do an entity relationship diagram for your projects. So you can think about that. So here this shows, these are the minimum cardinalities shown closer to the entities themselves. Is we have a supplier for a particular item. A supplier may not supply it at all, or they may supply many items. No, wait, an item has to have at least one. I'm not sure. I can't. I'm confused with this thing. An item has to have at least, can have 0 supplier. The supplier can supply no items, or 1. Okay, so I guess you can have, if you can have suppliers in your database, which you probably should be able to have suppliers that don't supply items. And I guess what this shows is that an item needs to be, a supplier must have at least one supplier. So that's what this is referring to. An item must have at least one supplier, and the supplier does not have to supply an item, so they put the 0 over here. So these are the maximums in here, and these are the minimums here. So these are called entity relationship diagrams. It's sort of a general term. The entity classes are shown as rectangles, relationships as diamonds. Maximum cardinality is shown inside the diamond. Minimum is shown by the oval or hash mark next to the entity. And so an item must have at least one supplier. And the name of the entity is shown inside the rectangle, and so here you see we're just using this particular notation that we showed earlier. And the name of the relationship can be shown underneath the diamond. Has just as a term used because these entity relationships has a relationship to a second entity relationship. Employees to badges and badges to employees. So we say that there's that this has a relationship. One entity has a relationship with another entity. And so this is sort of a history, and this crow's feet is kind of one that I like. And so this is this particular textbook, which is a textbook that I used a couple of years ago, likes the second crow's feet version also, as I do. So, so this is what the original ER model version looked like, and this is what the crow's feet model looked like. There's more information here. This says that this is a department. This is says an employee. An employee may be maybe not in a department, but the employee can be in no more than one department. Can be in no more than one department. So an employee can be in 0 or 1 departments, and a department can have 1 or many employees. A department has to have at least 1 employee, I guess, but a department can have many employees. And additionally, there is this dashed line here. What that indicates is that these are both strong entities, which means that they can exist in the database independently of each other. It's not the case where one needs to have the other one, needs to have an instance of the other one in the database for it to exist. We'll see examples of that. And so these are the different crow's feet symbols, and these are the symbols I like to use for a quiz. And this just summarizes these combinations. You can have there's mandatory 1, mandatory many, optional 1, and optional many. So this means you have to have at least 1. This means you have to have at least 1, but you could have many. This means that you can have 1 or none, and this means you can have it's optional, but you may also have many. And so these are the so here's an example of skill. An employee has got to have at least 1 skill, but the employee can have many skills. There's skills in there, and your database has got a list of skills, a table of skills, and you could have skills in there, and you don't have any employees that have those skills, but you also could have many employees that have a particular skill. You could have a skill can be had by many employees. And so if we just quickly go back to your quiz here. So I'm asking you to draw the crow's feet between these 3 entities that described here. And I've made it easy for you by showing you these relationships here, and so here I say make sure you indicate ID or non-ID dependence, which I'm going to cover, and the correct symbols showing whether the relationship is mandatory 1, mandatory many, optional 1, and optional many on each side. Okay, so make sure you get all those. So yeah. Okay, let's go on because there's more we have to cover here. Okay, so we have weak entities and strong entities, and a weak entity is an entity that cannot exist in a database without the existence of another entity. And anything that's not a weak entity is a strong entity. Okay, so we'll see an example of this in a moment here, maybe the next slide. Oh, that's ID dependence. Oops. Okay, an ID-dependent weak entity is a weak entity that cannot exist without its parent entity. Yeah. Okay, so there's a slight that sounds almost the same as this. This sort of this is more of a business rule where it doesn't make sense to have. Well, like we'll see in the next example, we'll see a couple of examples where a good one is if you have an entity that is apartments, apartments in a building, and you have this entity that lists all the apartments. It has all the apartments in Honolulu, but an apartment cannot exist without a building. So you have a building database or a building entity set of buildings, which is different. That's just addresses. But then you would have apartments, and apartments would have apartment numbers or whatever, unit numbers or whatever. But then they would also have to have an address along with it. So that's a weak entity and a strong entity. But ID dependent versus ID independent, again, just says that the weak entity can exist in the database and it doesn't require the strong entity to be able to identify it uniquely. And we'll see an example of that. Right here. Okay, here's some examples. Okay, so this shows that the orange means weak entity, and the fact that these lines are not dashed means they're ID dependent. Okay, so here's this example that I just mentioned. We have a building, and that building's got an address. Say it's a condo building. It's got an address, but the building also has apartments, and so you can so in this particular example, there's this building name which is like the key, because this is like the key, right? The building name is the key, and you have to make the assumption that in this example you make the assumption that all the building names are unique, I guess, and so you can have your apartment entity with these kinds of attributes, where you have the building name and then you have the apartment number, and those together make up the key, the composite key, and then the information specific attributes specific to the apartment. You can have products, you have a product name, and a bunch of stuff that are attributes of the product, but then you can have versions of the product. And so in this example, and that's so you can't have a version without a product, and you can't have an apartment without a building, you can't have an edition of a textbook without the textbook itself. But in these cases, these are ID dependent. You can't even refer to a version without the product name. You can't refer to this version without referring to this product, and you can't refer to this edition without referring to this entity here, because the title is, you have to when you refer to this, you're also referring to this, basically. So a relationship, and we'll see examples of weak entities that are not ID dependent. And we'll see examples just in just a moment. So a relationship between a strong and weak entity is termed an identifying relationship if the weak entity is ID dependent, and that's represented by a solid line. So the relationship is called an identifying relationship, and it's ID dependent. And it's represented by a solid line. A relationship between a strong and weak entity is termed non-identifying if the weak entity is non-ID dependent. And that's represented, relationship between strong, weak term, with a dash line, which is also used between strong entities. So let's, all ID dependent entities are weak entities. All ID dependent entities are weak entities, but there are other entities that are weak but not ID dependent. A non-ID dependent weak entity may have a single or composite identifier, but the identifier of the parent entity would be a foreign key. And so here's an example of the same, representing the same thing. One is ID dependent, the other one is not ID dependent. The dash, so anyway, so we have automobile models, a model of an like Toyota Prius, and then we have actual vehicles themselves. We have lots of Toyota Priuses, but this is like a class. This is an instance, and so this would be an ID dependent entity here if we use these attributes as the as the key to the vehicle. You have the manufacturer, the model, and then the manufacturing serial number. And so, this is whereas you could also, and so to refer to the vehicle, to find out the date that a vehicle is manufactured, you need to know what the manufacturer was, and then you need to know what the model was, and then you need to know what the manufacturing sequence number is, for example. Or there's this other way that we do it, and we have a VIN number, we have a VIN number, and this is the way we do it here, I guess in the world. And so, if you have a car, you have a VIN number. And I'm quite sure you know what that is because you need it for lots of things, insurance and all that. And so, so you can find out the date that your car was manufactured by the VIN number, and you don't need the manufacturer or the model or the manufacturing serial number or anything else. Okay, that's because there is databases like this available. Okay, now we're sort of up in kind of the theory world a little bit here because for you to actually implement this, you can implement this, but you still need a database which connects VINs to models, VINs to manufacturers. I mean, there's got to be more in your database than just this and this, because how do these two connect? Well, there's lines here, but there's got to be some table that connects them. So there's going to be, there's probably a table, or there would be a table that's got this in it, this manufacturer model in it, and VIN in it, and the VIN in it, and it would be a table which connects models to vehicle identification numbers, whereas that information is embedded into the actual keys themselves in this case. Okay, next here, here's some more examples. Here we have a salesperson and an order, and each of them are strong entities. A salesperson, there has to be at least one salesperson, or there has to be exactly one salesperson to an order, and then also a salesperson might not have any orders. A salesperson might have many orders, and so that's what is represented here. A salesperson can have 0 or more orders, and an order is associated with exactly one salesperson, not 0. Can't be 0. You can't have an order floating around there with no salesperson. And then so here's an example of where assignment is an ID dependent entity. It's a weak entity, and again, it's the same kind of thing where an assignment has got to have at least one. The assignment has got to be associated with exactly one project. The assignment is to work on a project, and you cannot have an assignment without a project. You can certainly have a project without any assignments. It could be that you haven't assigned anything yet, and you probably have many assignments associated with a project. So that's represented there, and the solid line indicates that it's ID dependent. Is that right? Yes, ID dependent. ID dependent is a solid line. Non-ID dependent is a dashed line. Since this is the only real reference to this provided by me, I'm kind of going over it again, and so you shouldn't have any problems writing down, expressing what you've learned from this lecture here. Okay, so and then we this third one here is patient like me, a patient when I go to the doctor, and prescriptions, and they're not ID dependent because you want to be able to refer to the prescription by itself. So that's why there's a dashed line there. A prescription can only be a prescription has to have a patient, so that's why it's weak. That's why it's so here we have that order is a strong entity, but then again I say you can't have an order without a salesperson. Each order has to have exactly one salesperson. That's a business rule. There's lots of cases where, I mean, you can imagine, lots of scenarios where you can have orders, but there's not a salesperson. I mean, like maybe the person bought it on the web or something. But here, but still with this, there has to be a salesperson associated with an order. For patients and projects, you can definitely see that an assignment floating around with not a project doesn't really make sense. And a prescription that doesn't have a patient, I mean, the prescription would never be in existence without first there being a patient. And so these are considered weak entities for that reason. And a patient may not have any prescriptions, but a patient can have many prescriptions. The older the patient gets, the more prescriptions the patient has. There's also these associative entities, and you should recognize associative entities from our suppliers database. Associative entity is used when there are attributes that are associated with the relationship between two entities. There's attributes associated with the relationship between the two entities rather than just the entities themselves. Okay, so in other words, an example is a supplier parts table, a supplier parts database where we have suppliers and we have parts, and then we have this other table that's SP, that's got the parts that are being shipped, and that table, the SP table, you recall, it's got a composite primary key with the supplier, the part, and the quantity. So this quantity attribute is associated with both. It's associated with the relationship between the two entities, the supplier entity and the parts entity. And so that's called an associative entity, so usually and this is what we did. This is the implementation of it. The new entity, a new entity is then created to link the two original attributes and link the two entities. That's going to be the primary. That's going to be the composite primary key, and then also holds the attributes. So that's the quantity field. So here's an example, and we've seen this example also. We've seen this employee project assignment example in quizzes and so on. The actual relationship, this many-to-many relationship between employees and projects looks like this. And this is how you draw. This is how you would draw it if it were a question on a test. This is how you draw it. But even if you were just to implement this and you don't have hours worked, okay, let's say you're just going to implement this here. Well, you still need this third table here. Okay, I mean implementation-wise, because you know to represent an employee working on several projects, you need to have a table that's got project and you would need to at least have a table that has the employees. No, an employee can work on several projects, so you at least have to have a table that's got an employee number and then a project ID, and you would need to be able to, that table would need to be able to be filled with entries, with more than one entry per employee. And then if we assume that, we would assume that an employee can only work on one project once, the employee cannot be working twice on a project. So then the primary key for that middle table here would then be employee project, just like it is here. But it's very, very often the case that it's more than just connecting something like this without having some extra data there along with it. And so, but once we do put this thing in there, this third entity in there, we can redraw these lines, and this actually is how we would implement this. So this is a a weak entity. This assignment cannot exist without an employee. It cannot exist without a project. So the lines are they are it's ID dependent. So if it's ID dependent, it's a weak entity to begin with. But so the employee here, this ID of the ID of this assignment depends on the ID of the employee, so it's a solid line. The ID of the ID of the assignment also depends on the ID of the project, so that's why this is solid. An assignment, a particular assignment, an instance of an assignment in here is going to be connected to exactly one employee. It's going to be connected to exactly one project. And an employee can be assigned to more than one project, and an employee might not even be assigned to any projects. That's what the 0 is there. And a project may not have any employees, which is what the 0 is here, or a project can be assigned to many employees. A project can be assigned to many employees, which is why you have the crow's foot there. And I think this is the last thing I'm going to talk about in these slides today, and that is subtypes. So for subtypes, subtype can be, let me show you, just show an example of a subtype. This is a relationship there also. And here's an example of subtypes. So let's say it's a student database at UH, and there's a student record for you, but along with that there is you have undergraduate. A student can be an undergraduate or a graduate student, but not both. So the is-a means that there's a relationship between this and this. This is a with this, and same with this and this. And this X here means exclusive, exclusively this or this. And then you have so these are exclusive, but then you can have inclusive subtypes also. So these are the subtypes down here. You can have inclusive ones where a student can be a member of both the hiking club and the sailing club. So this is not like where you're using the same space in a record to either store undergraduate data versus graduate data. It's not like that. It's a separate table. It's a separate entity that are connected in some way, namely the student ID. And you can have you would in a case like this, if a student can be a member of, well, there'd be the hiking club entity and the sailing club entity, and it's connected to this by the student ID. So a student can only be a member of the hiking club once, can't be twice a member. And so this works the way it is here. We wouldn't need any intermediate tables or entities. And then, of course, entities can be recursive like this. The relationship can be recursive. And where a customer, let's say you have a referral, let's say you want to save if a customer was referred by somebody else. So then you could do something like this, where you have a referred by field, and that's okay. So you can have a customer. A customer can either be referred by somebody else or not, but not by two people. Only a customer can only be referred, by one other person. Whereas the referrer, the one doing the referring can refer many customers. So that's, or no customers. So that's this one up here. That's like you can have an employee table, an employee entity, and you can have an attribute in there which can be boss, and an employee, and so that would be a recursive relationship, and an employee can have no more than one boss, preferably, and but an employee can be the boss of many employees. I suppose the president or the top guy in the company would not have a boss. Presumably, that's the only one. Okay, and then this goes on with an example of actually taking a reading from taking an existing organization and with all of the entities in their database and drawing the entity relationship diagram from that. So I'm not gonna go through this. I'm gonna come up. Your assignment, I will write up the assignment where I want you to take your project and do an entity relationship diagram. I want you to do all of this where you'll be coming up with the full definition of the tables, but also a nice documentation, a drawing like this would can just be an assignment. All right, are there any questions on this? I've pretty much covered what I'm going to cover today. I'm sorry, the what? Oh, it's only by a client. Yeah. So let's see that. A client may have property and share ownership with other clients. Yeah, so right. I just this example came out of somewhere. It was just a problem, and they didn't give the full context of what these agents were, and I don't know. It could be it could even be a property management company or something. Yeah, that's what I put here. But there's other things that this could be where you have clients with properties. All right. So you can finish the quiz, and you only have 15 minutes, no problem. If you need to take it home, you can do that and hand it in next time. All right.